Howdy, my name is Tyler Dane Williams, and my senior thesis for INTS 4350 Capstone Integrative Studies is over drought in Texas and its direct relationship to groundwater levels. I chose this topic because it is very important to me because I plan on working in the livestock industry upon graduation. In this presentation, I will discuss past droughts, groundwater levels, and their direct effect on Texas's economy. Texas has constantly been plagued by drought. The Texas area is one of the driest, most drought-prone areas in the United States. Texas relies on the agriculture production industry to support its economy. In a drought, Texas is forced to use large amounts of groundwater to meet the demands of the agriculture industry. The amount of water supplied by aquifers and the amount of rain necessary to recharge them is a growing concern. Having adequate water supplies is necessary not only for the agriculture industry, but for the citizen population as well. With the continued drought, Texas is forced to overstep its water withdrawal from aquifers at alarming rates. This thesis is used to show a relationship between drought and groundwater depletion. It will also cover past research conducted on drought as well as legislative actions taken to prevent overconsumption of Texas groundwater. For the past 3 years, Texas has been experiencing detrimental ecological problem that most citizens are unaware. Drought. Texas is currently in its third consecutive year of drought, and farmers and ranchers are praying for a change. The effect of drought are felt statewide by farmers, ranchers, and the agriculture industry, and it's crippling blow to the Texas economy. Drought does not just prey on landowners and farmers, it also takes its toll on everyday citizens who require adequate groundwater supplies to support their daily activities. With no current solution to the problem, actions must be taken to preserve Texas's groundwater and determine possible solutions to this ecological threat. We all know drought is not a new concept here in Texas. In fact, when the Spaniards first explored the area in 1520, thousands of their horses perished because of lack of water and forage. Whole rivers dried up, forcing many missionaries to abandon their settlements and move to wetter climates. Stephen F. Austin's first settlers were also devastated by drought in 1882 when their crops died due to a lack of rainfall. The most devastating drought Texas has experienced in the last 100 years was in 1950, but that all changed in 2011 when we experienced our driest year on record. A main issue that relates to Texas's current drought is the depletion of groundwater. Aquifers are dependent on recharge from infiltration of precipitation. Therefore, in a drought, the amount of infiltration is dependent on rainfall. With no rainfall on the horizon, aquifers are currently at their lowest level in years. While it is obvious to consider water an important natural resource, many individuals underestimate its actual value. 33% of water that county and city water departments supply to households and businesses come from groundwater withdrawal. Groundwater alone supplies 97% of the rural population with its drinking water. So with the recharge rate of groundwater decreasing and drought persisting, actions must be taken to prevent future unrest. The problem is there's no way of predicting an end to drought. Therefore, we must look at the current situation and apply new techniques to aid in this issue. An interdisciplinary approach is necessary because there are so many different factors that contribute to this problem. One is forced to look outside the box for new solutions. An interdisciplinary approach would be most effective because you can look at the problem through multiple lenses to find potential solutions. This problem is perfect for interdisciplinary inquiry because no single discipline has been able to explain it comprehensively or resolve it. Potential causes of drought and groundwater depletion must be found to help prevent future problems. Investigating the possible causes of drought and the direct relationship it has to groundwater must be studied to determine a connection between these issues. The severity and longevity of drought both need to be studied on a physical, financial, and ecological scale. The two disciplines that I chose that are directly related to this topic are history and earth sciences. These two disciplines do not have much in common, but pulling information from these two can potentially give new information on how to deal with this ongoing problem. History is very important when looking at drought for many reasons. For one, we can look back at records kept on rainfall per year and groundwater levels per year and determine if they are directly affected by one another. It is very important to find a common trend between rainfall and groundwater depletion. A historical perspective could also look at how ranchers and farmers have handled drought in the past and possibly connect those methods to current methods and look towards new technologies to solve the problem. Earth sciences is equally important when considering drought. One has to know how drought is affecting the ecosystem. Without this information, we have no idea how bad the current drought is or the negative effects it's having on the agriculture industry. Using earth sciences, we can better understand the amount of damage drought is causing to Texas's delicate ecosystem. A key aspect of drought is understanding what drought is. Since there are many scientists looking at the issue, there has to be an understood definition of what drought is. Much of the confusion about drought results from different perspectives of how to define it. The beginning and end of drought are hard to recognize because drought is a gradual phenomenon. Most drought definitions are based on meteorological observations, agriculture problems, hydrological conditions, and socioeconomic considerations. For this reason, the definition of drought is determined on how these four perspectives blend together. Therefore, multiple people are using multiple different methods with different definitions, and this is not beneficial when trying to collaborate data. Historical research done over this topic is extensive due to the fact that Texans have dealt with drought since 1520. Texas has experienced harmful effects from drought financially and ecologically. Research done in 2011 drought showed the 12-month rainfall total from October 2010 to September 2011 was far below the previous records set in 1956. Average temperatures for June through August were over 2 degrees Fahrenheit above previous Texas records, and were close to the warmest statewide summer temperatures ever recorded in the United States. This drought was the worst Texas has experienced in recorded history. Due to the severity, many research is focused on this one-year period to increase awareness of the ongoing problem. A historical perspective allows us to understand past issues and causes of drought. A study done over the Texas-Oklahoma drought of 1998 gives us a possible cause for drought. It was determined that drought is not caused by human interaction, but is related more to climate change and extreme weather conditions. Groundwater is contained in underground aquifers. The Ogallala and Edwards Aquifer are both exhaustible resources. For this reason, actions must be taken to stop needless consumption of Texas's limited resource. A study was conducted using 4 counties in northern Texas that relies on groundwater from the Ogallala Aquifer. Of these counties, agriculture was the main source of groundwater withdrawal of 89. In conclusion, the direct relationship between groundwater withdrawal and recharge rate shows that in a particularly dry season, the recharge rate will not cover the amount of water taken from the underground aquifer. Combination of large demands for usable water in drought-prone areas causes a negative effect on the aquifer levels. This negative effect then causes streams, groundwater recharge stations to dry up, preventing future recharge rates. If an early warning system were created that used collective information from all available resources that use the same definition of drought and data collection methods, federal regulations could be enacted to protect the potential drying out of our aquifers. But that alone will not be enough. The federal government needs a better response method when a drought occurs. The severity of drought directly reflects the amount of water used from aquifers. In a continued drought, recharge rates of these aquifers is non-existent. Therefore, we must use legislative actions to control the withdrawal of groundwater. Thank you, Go Tech.